In section 4.1, we will talk about area and the definite integral. So far, we have only worked with derivatives, but in this section, we will be introduced to integrals, which are the exact opposite of derivatives, and they're also called antiderivatives. Before we get to all that, let's say a car is traveling at 40 miles per hour. Write an equation to represent the speed of the car. Now, the speed of the car, it's constant. It's 40 miles an hour. It's not changing. So our equation is just going to be s, which speed of the car, is equal to 40. It's not increasing. It's not decreasing. So there's no variable. It's a constant speed of 40 miles an hour. Let's sketch a graph for this. So if this is now it's 40 miles per hour. So let the x-axis be the number of hours traveled, and the y-axis be the speed. Then the speed is, this is 10, 20, 30, 40. Every hour, the car is going 40 miles per hour. So no matter how many hours we travel, the car speed is not going to change. It's going to stay constant at 40 miles. So this line up here, this represents the speed of the car, which is 40 miles an hour, and this is the number of hours traveled. Okay, so now next question. How far has a car traveled in 2 hours? So let's think about this. A car starting here, and in 1 hour, it's gone 40 miles. So in 2 hours, it's going 40 miles per hour, so it goes another 40 miles. It's traveled a total of 80 miles. We can see that on the graph too. So if I make this a rectangle, this is my speed, this is the number of hours traveled. In 1 hour, the car is going 40 miles. So I'm basically multiplying the number of hours times the speed. In 2 hours, it's going 40 plus 40, or a total of 80 miles. So this area here, it represents the distance that the car has traveled. How far does a car travel between the 3rd and 6th hour? So I have to actually make my graph a little bit longer. So let me adjust this a little bit. Okay, now we want to know how far has the car traveled between the 3rd and the 6th hour. So this car is going to keep going. And between the 3rd and the 6th hour, it's going 1, 2, 3 hours, and it's going 40 miles an hour. So we got 40 plus 40 plus 40, which is 120 miles. Okay, which makes sense, right? It's going 40 miles per hour. We're traveling for 3 hours, so 40 times 3, that's going to be 120 miles. But here's what we want to recognize, that the area under the curve, this represents the distance traveled. We got the speed on one axis, we got the number of hours on the other axis. So the area under the curve, it represents the distance traveled. Here's another example. The velocity of a moving object is given by the function v of x equals to 2x, where x is in hours and b is in miles per hour. Use geometry to find the area under the graph, which is the distance traveled by the object. So once again, over here, if we have speed on one axis and the number of hours on the other axis, then the area under the curve is going to be the distance traveled. Same here, except our speed is given by not a constant function like 40 miles an hour, it's given by a function v of x equals to 2x. Basically, here's what that means. It means that in 1 hour, the object is traveling at 2 miles per hour. In the second hour, its speed increases to 2 times 2, which is 4 miles an hour, and so on and so forth. So first, use the geometry to find the area under the graph. For that, we have to sketch a graph. So what do we say? We said that the y-axis represents the speed and the x-axis represents the number of hours. So the equation is this, is v of x equals to 2x, which is like 2x plus 0. So if we were to graph this, then our graph is going to start at 0, because at 0 hours, the speed of the object is nothing. It hasn't moved yet. Then the slope is 2 over 1. So every hour, the velocity increases by 2. So the first hour, it's going at a rate of 2 miles an hour. And then you increase it by 2 over 1 again. So this is 1, 2, 3, 4. After the first hour, the speed is 2 miles an hour. After the second hour, the speed is 4 miles an hour. After the third hour, we can go up 2 and over 1. The speed is increased to 6 miles an hour. So this is first hour, second hour, third hour. Fourth hour, it's increased to 8 miles an hour. Okay, and so on and so forth. So this line, it represents the velocity or the speed of the object. And the speed isn't constant. After 1 hour, the speed is 2 miles. 2 hours, speed is 4 miles, etc., etc. Now, the question says, how far has a car traveled in 2 hours? Not the speed of the car, but how far has it traveled? And the distance traveled is the area under the curve. We want to find this area right here. The area under the curve when the x is a number of hours, y is the speed, it represents the distance. So to find the area under the curve, which is the distance, we have a triangle. We're going to apply the formula for the area of a triangle, which is 1/2 times base times height. Okay, so the base here is 2, and the height is 1, 2, 3, 4. So the area is going to be 1/2 times the base, which is 2, times the height, which is 4. 1/2 times 2 is 1, 1 times 4 is 4. So in total, this object has traveled 4 miles. If I were to track the progress, this is at 0. In the first hour, the speed is 2 miles an hour. So it's gone 2 miles. Okay. Then it increases the speed in the next hour to 4 miles an hour. So it's gone 2 more, and so on and so forth. All right, now how far does a car travel between the third and the fifth hour? So for that, we need to go one more over here. So I'm going to make this into 5. Now at 5, we're going to go up 2 over 1. So we're going to get to 10. So this point is 5 comma 10. Okay, the speed has reached 10 miles an hour. So here's what we want to do. We want to find out between the third and the fifth hour. So this is hour 3, and this is hour 5. Now the distance traveled is going to be the area under this curve. It's going to be this entire area, this whole thing. To do this, we're going to split this up into two parts, into a triangle and also into a rectangle. So we got to find individually the area of this triangle and the area of this rectangle. And if we add these up, then we will be given the total area. So first, let's find the area of the rectangle. So at 3, the speed is, if you go to over here, it's 6 miles an hour. So this height is going to be 6. And we want to find the how far does a car travel between the third and the fifth hour? So the base here is going to be 3, 4, 5. That's going to be 2. If you multiply 6 times 2, then this area is going to be 12. So it's traveled 12 miles an hour in this little part. Then we got to find out what is a base times height. So the base here, once again, is going to be 2. And for the height, we're going from 6 to 10. So we're going 1, 2, 3, 4. The height's going to be 4. The area of the triangle is 1/2 times base times height, which is 1 times 4, or 4. So this area is going to be 4. So the total area is going to be 12 plus 4, or 16 miles. Here's a key point I want you to understand. That the area under the curve is important because it represents a total amount of something, such as total distance, total profit, total cost, etc. So this chapter is going to focus on finding the area under the curve between two values because, again, this area is going to represent something important. And this is called the definite integral. Definite means it has a starting point and an ending point. That is a definite integral. Integral refers to the area under the curve. Okay, so here's the definition of the definite integral. If f of x is continuous on an interval and is non-negative, the definite interval, the definite integral rather, is the area below the function and above the x-axis. So that's important. I'm going to write that here. The integral, this is the area below the curve and above the x-axis. We got to understand that definition. It's the area below the curve and above the x-axis. So basically between the curve and the x-axis, that's going to be the definite integral. And then a and b, these are called the limits of integration. If we're taking the integral from a to b, which means we want to find the area under the curve but above the x-axis from a to b, then a and b are called the limits of integration. Now sometimes the function will be below the x-axis. When it happens, then the area is going to be a negative value. So here we have a graph over here that the area above the x-axis is going to be positive and the area below the x-axis is going to be negative. And the total area is going to be the area above the x-axis minus area below the x-axis. So if a function is continuous and is both positive and negative, then the definite integral is the area above the x-axis minus the area below the x-axis. Here's an example of that. Evaluate the integral below by interpreting it in terms of the figure. So here's what we know, that we want to find the area of this function under the integral of this function from 0 to 7. Okay, so we want to find the area between the curve and the x-axis from 0 to 7. And here's what we're given. A1 is 10, so this is going to be 10. A2 is 6. A3 is 2. And A4 is 3. Okay, so in order to find the area under the curve between the curve and the x-axis from 0 to 7, we're going to add all of the areas from 0 to 7. So this is 0 and this is 7. So that means we have A1, A2, and A3. Okay, so we're gonna add all these up. So A1 is 10, but A2, the area is going to be negative because it's below the x-axis. So it's going to be plus -6. A3 is above the x-axis. It's 2, so that's going to be 2. So from 0 to 7, the integral of f of x is going to be 10 plus -6, which is 4. 4 plus 2 is going to be 6. 10 minus 6, which is 4. 4 plus 2 is 6. Another example, the area in the graph is equal to c to d, f of x dx, where c and d, these are the limits of integration. So we got to figure out where we're looking for the area under the curve, but over what interval. So the interval starts over here, and it's going to go all the way until here. So it's going from -3 to 3. So this is saying the limits of integration are going to be -3 and 3, where c is -3 and d is +3. And we have this line in the form of y equals to mx plus b, right? So what is m and what is b? So m is a slope. So the slope, I can take any point here, and I got to find another point that's like exactly on the, like at the edge of two lines. So that's going to be this point here. So my rise is 2, 4, 6, 8, and my run is 1, 2, and 3. Okay, so it's 2, 4, 6, 8 is my rise, my run is 3. So my slope is going to be 8 over 3x. And my y-intercept is a point where the graph crosses the x-axis, so my y-intercept is going to be 0. So my function is just 8 over 3x plus b, which is 0, or 8 over 3x dx. Limits of integration are -3 to 3. Those are the x values over which we're looking for the area. And the function is just this line, which has a slope of 8 over 3, y-intercept of 0. That's going to be 8 over 3x dx.